which is the, well, so in short, today we're going to look at parabolas and hyperbolas. So let's first start by looking at important features of a parabola. So in short, when you've been asked to discuss a parabola, what you need to show are these. You need to show the axis of symmetry. You also need to show the focus. You also need to find the vertex and also the directrix. So this is the general equation for the parabola here. The parabola's general equation is here. And then, so that's the general equation for the parabola. And then we also have this one here. So when you have this equation here, the parabola will either be, the parabola will either face up or down, depending on the value of p. So if p is greater than 0, so if p is greater than 0, it's going to face up. And then if p is less than 0, it's going to face down. And then when you have something like this, it will either face this side or that side. So the same applies here. When the value of p is less than 0, to face this side, to face the negative side. And then when the value of p is greater than 0, it will face the positive side. Yeah, so this is what it means. And then let's look at the types of parabolas. So the types are just what I'm just from explaining here. When you have this equation here, which has x minus h being squared, it means that your parabola is going to either face up or down. This equation is just the same as this one here. And then when you have your p greater than 0, meaning your p is positive. So if your p is positive, the parabola will face to the positive side. It will face up. And then when your p is negative or p is less than 0, your parabola is going to face down. And then the same also applies to this. When you have y minus k being squared, it means that your parabola will either face to the right or to the left. And if your p is greater than 0, your parabola will face to the right. And then if your p is less than 0, your parabola will face to the left. So, yeah. And then these are just the equations of the directrix. The equation of the directrix is here, depending on the type of parabola you're dealing with. So let's take a look at this example here. So you find the equation of the directrix and the coordinates of the vertex and focus of the parabola given by the equation that. So you remember what we were doing yesterday, where we said we first need to express this equation in the standard form of a parabola. So sometimes you may not be told whether the equation is for the parabola or for the hyperbola, or it's for the ellipse or the circle. They'll just give you the equation and tell you to discuss the equation. So it's up to you now to reduce it to the standard form. And then the final answer that you're going to find is the one that will show you whether that's a parabola, an ellipse, or that's a circle, or maybe that's a hyperbola. So let's express this in standard form. So remember what we said first. You can take you first collect the like terms. So the like terms here that we have 2y squared and then we have plus 8y being equal to, I'll take this negative 4 to the other side of the equal sign to become a positive, and then I'll take this 3x to the other side of the equal sign as well. So this would be a minus 3x. So here now we complete the square on the left hand side of the equal sign this side. So what you do when completing the square, you first factor out the 2. When you factor out the 2, rather you factorize the 2, you are going to have y squared, and then plus, this will be 4y. This is equal to 4 minus 3x. So after factorizing this side, you now find the half of this 4. So you factorize and then now find the half of that 4. So the half of this 4 is going to be 2. And then this 2 that you find here, you square it. Then you subtract with this same 2 squared. And then add that same 4y there. Then you close the brackets and then say is equal to, this is 4 minus 3x. So from there, what you do here, you are going to have 2 and then open brackets. So we put these 2 in brackets, we're going to have y plus 2 and then put them in brackets and then square them. So this is going to be minus, and then 2 squared, you get 4. So you forget about this, because when you expand this, you're going to have that in your expansion. So you forget about it. And then you close the brackets. This is going to be 4 minus 3x. And then from there, it's now just we're just remaining with now multiplying these 2 throughout. So meaning we're going to have 2 open brackets, y plus 2, and then squared minus 8 is equal to, so this is equal to 4 minus 3x. And then what you do here again, this will now be equal, you take this 8 to the other side of the equal sign. You're going to have 2 open brackets, y plus 2, then squared. So when this 8 goes to the other side of the equal sign, it will become a positive 8. So it will be 4 plus 8 there, you get 12. So you're going to have negative 3 there, and then negative 3x there, and then you're going to have positive 12. When you add 4 plus 8, you're going to have positive 12. So our aim is to make this equation in the standard form of a parabola. So how are we going to do this? So you now open the brackets like that, and then you say y plus 2, then squared, this is equal to, so when you factorize this 3 here, this negative 3, you are going to have negative 3 outside, and then open brackets, then this is going to be x minus 4 in brackets. But remember, there's a 2 this side. When you divide by 2 this side and then divide by 2 even this side, you're going to get your 2 there. Yeah, so from there, we can see now to say this equation is in the standard form of a parabola. So after this part now, you go on to finding the value of P, because you cannot, without you knowing the value of P, it will be difficult for you to tell whether your parabola is going to face to the right or to the left. So how do you find the value of P? Remember in the equations, these equations, we said 4p is the one that is the coefficient of this part which is not squared. So in short, my 4p according to this is equal to -3/2. So I'm going to equate this 4p to -3/2. So my p will now give me something like,
Where is the denominator to come?
when you divide 2 this side, you also divide this part by 2. These 2 cancel with that 2, and then I'll remain with this. And then this side also, I'm going to have these 2 outside. You have gotten it? Yeah.
Yes, thank you.
All right. So here you find your p. You're going to have -3/8 as your p. So having found the value of p, we can now try to sketch our graph. First of all, let us also write our center in advance. So our center is, you get this part, you equate it to 0, and then make y the subject. This part here, you equate it to 0, then make y the subject. You are going to have your y to be -2. And then for x, you equate this part to 0, and then find the value of x. You are going to find your x, or sorry, your x is going to be +4. So after finding the center, you now need to see first your graph. Is it going to come out like this, or like this, or maybe like that, or like that? And how do you tell? So this parabola, when you look at the part which is squared, is y. So when y is squared, it means that we're going to have our parabola either face this side or that side. But how do you know whether it's facing this side or that side? How do you know? You look at your value of p. Remember we said when the value of p is positive, it's going to face to the positive side. When the value of p is negative, it's going to face to the negative side. So if we were to sketch our graph here, it's going to look something like, it's going to look like this. So this is our center O, and then the center of this parabola is going to be equal to, it's going to be this part which is 4, -2. So if we were to plot this 4, -2, it's going to be here, maybe at this point 4, -2. It's going to be somewhere there. So this is going to be our center for the parabola. So now, if this is the center, we know to say, since this p is negative, it's going to face to the negative side. So if this parabola is to be sketched, it's going to look like this. It's going to look like this. So this is going to be the parabola. And then this, this part I'm calling the center is also known as the vertex. And then you can find the directrix by adding this, or by subtracting this, this p that you found here from 4, and then you find your focus, which is inside there. I mean, you find your focus by subtracting this from 4. I mean, the directrix is found by subtracting this from 4, and then the focus will be found by adding this and 4. So the focus is just in the same line as the directrix. So the directrix, maybe it will be somewhere there, I'm just approximating. And then when you add this 4 plus this 4 plus your negative 3/8, you get your answer to be, this is 32 minus 3, you get, is it 29? So it will be 29. So it will be somewhere there, 29/8. This is your focus, 29/8, comma -2. So this is going to be your focus here. And then to find your directrix there, the point, the line, or the line where your directrix is going to pass, at the point where your directrix is going to pass, you say 4 minus this negative 3/8. Then when you add the 2, you are going to have 35/8. So meaning 35 at this point, 35/8. So it's going to be like this. So this is 35/8, comma -2. That is the point where directrix is going to pass. But this line itself is just x is equal to 35/8. That is this line. And then your focus will be there. And then there's also a need for us to find the line of axis. So the line of axis is just this line which cuts the parabola into 2 equal parts. So this one is just given by y being equal to, with this 2 here, this -2. That is the line of axis. And then when you're sketching also, you can also find 2 points at least in the parabola, just to show you the direction of this parabola. If you don't know, if you can't tell whether this is facing to the right or to the left, you can find 2 points, you see where you're going to go. So you can test them by saying, okay, let me try to say maybe my x is -1. Oh, yeah, I'm just remaining with 10 minutes. All right. So you can try to test any 2 points just to see where you're going to go, whether the graph is going to go this side or the graph is going to go this side. But if you are able to tell from just the equation that this graph is going to face this part, it's there's no problem. You can just go direct to sketching without finding any 2 points. So I think we can proceed. There's no other question. If you don't have questions on this one, I think we can proceed. Okay.
Mr. Teddy.
Yeah, Vivian, you realized. Yeah, what was the question, by the way?
I wanted to know how you knew that it was going to face in towards the negative, because you also said that it can either face upwards or downwards.
Yes. Okay. For parabola, let me just give you one clue. And it always helps me to identify whether it's facing to the negative or to the positive. Have you ever tried to sketch a graph of a quadratic equation? Like this. Maybe you have something like this. Quadratic equations, every time you're sketching quadratic equations, your sketching or your curve is always going to come out it's going to either face upwards or downwards. If you can remember very well, last semester we used to call these graphs to say maybe this has the maximum or this has a minimum. So when you look at this one, since the value of a, which is the coefficient of x squared, is positive. So if the value of a is positive, it means that you are going to have a minimum. It's going to be minimum, meaning it's going to face up. And then it's maximum when the value of a is negative, meaning it's going to face down. So my point here is that if you want to know whether this graph is facing up or down or to the right or to the left. You first need to know whether its line of axis is parallel to the y-axis or its line of axis parallel to the x-axis. So the line of axis is the one that cuts the curve into two equal parts. So like this. So you need to know whether the line of axis is parallel to the y-axis or the line of axis is parallel to the x-axis. And then how do you know that? Take for instance, this is a quadratic equation. A quadratic equation, every time we're solving quadratic equations, x was squared. And x, when x is squared, when x is squared, the graph always comes out either facing up or down. So meaning the opposite is for y. So meaning if we have y being squared, meaning the graph instead of facing up or down is going to either face to the left or to the right. I don't know if this has helped you. But if you want to know whether it's facing to the left or to the right or up or down, you first need to know this concept which I've said here. I don't know.
Thank you, Mr. Ted. You have gotten it.
You've gotten it, right? Yeah. So now if you want to know whether it's facing to the left or to the right, after identifying that my y is positive, my y is the one which is squared. After identifying that, if you want to know whether it's facing to the left or to the right, you need to look at the value of p. So when the value of p is negative, then it will face to the negative side. When the value of p is positive, it will face to the positive side. That's the way it is. So first of all, you need to identify whether it's y which is squared or it's x which is squared. So this is what we are trying to sketch here. And we sketched it. Right. So here on this one, I'm just going to explain in just this remaining 5 minutes. And then we generate another link, which we're going to start looking at hyperbolas. So when you look at this part here, the one which is squared here, when you look, first let me explain on this one. Here, y was squared. Hence the graph was expected to either come out like this or like that. The reason why it came out like this, it faced to the negative side of the number line, is because our value of p was negative. That's the reason why it faced to the negative like this. And then here, the y was squared, meaning it's going to either face to the left or to the right. So now, in this case, when x is squared, meaning we know to say it's either going to face up or down. When x is squared, it's either going to face up or down. So since the equation is already in its standard form, it's now easier for us to do what? To just find the value of p. You just say 4p is equal to these two here. So meaning your p will now be equal to 1/2. When you divide 2 by 4, you get 1/2. So your p is positive. So since your p is positive, we know that my graph will either be up, will either face up or down. But I know that p is positive, meaning it's going to face to the positive side. So meaning this one is irrelevant. Let us find. So this is how my sketching is going to come out. It's going to face up since my p is positive. And then what else? I also need to find the center, which is the vertex. So the center, or let me be using v. The vertex v is just given by, so you equate this part to 0, then you get your x value to be -1, comma, you equate this part to 0, you get your y coordinate there to be +3. So having found this vertex, you can now even go to sketching your graph. You know to say my graph will face upwards. First, let me put my my coordinate there to be -1, comma, this is my center, comma 3. So it's going to be somewhere there. And then I know that it's going to face up. So I just need to find the directrix. I need to find the directrix and the focus. So the focus is supposed to be inside there. Then directrix is supposed to be outside. So how do I find the focus and the directrix? Just by adding this p and subtracting it from, in this case, we're going to be adding and subtracting it from these 3 here. So when we subtract 3 minus half, 3 minus half, I'm going to get 2 point something, which is yeah, okay, I'll just write in decimal, which is 2.5. So I'll just write my 2.5 there. So this is going to be my directrix. And then my focus there, I'm going to add 3 plus half, which is going to be 4.5, 3.5, which is going to be somewhere there. So I'll just put my 4.5 there. So this is where my focus is. So you just need now to find the coordinates. You just get the coordinates, which are -1, comma 4.5, -1, comma 4.5, and -1, comma 2.5 here. Meaning this line will be denoted by y, or this time around to be y. To be y. Y is equal to 2.5.
So,
Then, okay. Okay, I'm getting you.
so I'm not clear on the focal point.
On the focus.
Yeah, I don't know if it's the focus or what.
The focus is just, okay, to find the focus, the point is record. Thank you very much for reminding me. So these are the key points of, these are the key points on the hyperbola. You just need to find the vertex, the foci, and then the conjugate axis. Yeah, no, actually the conjugate axis is not even that important. The one which is important is the transverse axis. Okay. So these are the types of hyperbolas that we have. We have this one which is facing on both the right and the left, and then we also have this one this side which is facing both on top and down there. And then the other things that are important on the hyperbolas are the asymptotes. The asymptotes are very important. For this one, the asymptotes to move like that, and then to also move like that. So this is the general formula for the hyperbola, which has the center 0, 0. So the center here is 0, 0. That's why you are not able to see the h and the k in this equation. Same applies to this one, this side. The center is 0, 0. That's the reason why you are not able to see the h and the k in this equation. And then what you should understand is that if in this case, we're not going to look at which value is greater for us to determine which one is A and which one is B. In this case, we just have to know to say, every time the one which has, the part which has, or rather the part which is positive is the one that has A. The one which is negative is the one that will go with B. That's the way it is. And then apart from that, you also need to know that in this case, when finding C is given by, instead of having A squared minus B squared, for the hyperbola, here there is a plus. Why do we put a plus? Because the distance, this C is just the distance from the center to the focus. So this C is just the distance from the center to the focus. So we move. Yeah, so that's what I'm just from explaining. Then eccentricity is given by C over A as well. So the asymptotes of the hyperbola with center at the origin, I've explained on this. Yeah, let me just shed more light. So the asymptotes are given by these formulas here. Or what you do, if you can't find this, if you don't know which one is your A, which one is your B, or if you want to get your asymptotes without making silly mistakes, you just put a 0 there. While there is 1, put a 0. There's a problem with network where I am. Okay. So I was saying this is the question here. Then it's asking us to find the vertices, the foci, and then the asymptotes. So here, what you need first to identify is your A, your B, and your A, your B, and your C. It's very important to find the C in advance. Of issues with network here. All right, I think to not do that again. Okay. So I was saying you find the vertices, the foci, and the asymptotes, and then so to do that, what you need to do here is you first identify which one is your A, which one is your B, and then we said A is always on the positive part. So here our positive part is y squared, so meaning our A is just under y squared. So my A squared is equal to 9, meaning my A is just equal to 3. Of course, it's supposed to be plus or minus 3, which is just the same. Yeah, it's supposed to be plus or minus 3. And then this is my A. You also find your B. So my B squared is equal to 4, meaning B itself. So B itself will be equal to 2. So from that, we can now find C. So C squared is given by A squared plus, for the hyperbola, A squared plus B squared. So C squared is equal to, my A squared is 9, and then B squared is 2. Oh, sorry, it's 4. So when I add the 2, I'm going to get my C to be equal to, this will be 13, meaning the square root of 13 will be my C. So that's the center. And then what you need to do here now is to move 3 steps. So our center, of course, is 0, 0. Let us first find our center. So our center is, of course, 0, 0, since we don't have h and k in that equation. So our center will be 0, 0. And then we can now find our, we can now start sketching. So we're going to move B steps in the, X. So meaning we're moving 2 steps in the X, 1, 2. And then even this side, we move the same 1, 2. And then you move 3 steps in the Y, since my A is under Y there. So I'm going to move 3 steps in the Y, 1, 2, 3. And then even this side, 1, 2, 3. Then I'm going to draw I'm going to draw a small box here. I'll draw it in dotted lines like that. So from there, I'll draw my asymptotes. Okay. So the asymptotes are supposed to pass through the center of your hyperbolas. And then, so this, since my A, yeah, since my A is under 9 this side, since my A is under 1, so meaning this is going to either face, it's going to face up, so it's going to move like this. And also like that. And then to find the equations of the asymptotes, remember what we said, you just equate this equation to 0. So when you equate this to 0, you take this to the other side of the equal sign, you are going to have something like this: y squared over 9 is equal to x squared over 4. This is supposed to be squared over 4. So you can cross multiply here. You're going to have y squared is equal to 9 over 4x squared. So you find the root this side, you find the root that side. So you're going to have your y being equal to plus or minus, the root of 9 is 3 over 2, and then x. So these are the two equations of the asymptotes, because there's a positive 3 over 2x and the negative 3 over 2x. So the one with the positive gradient is this one. So the equation of this one would be y is equal to 3 over 2x. And then the equation for this one, which has the negative gradient, will be equal to y is equal to negative 3 over 2x. So this is how you sketch hyperbolas. I don't know if I've forgotten anything, but I think I've explained everything. Yeah, so what I was talking about. Oh, I forgot to put the focus. So the focus there is just C. You just add C to the what? You just add C to the center. Our center was 0, 0. Yeah, our center was 0, 0. So since this hyperbola was in the y, so meaning we're going to add our C, which we found to be the root of 3. You add to the y coordinate. Since it's in the y, you add to the y coordinate and subtract it from the y coordinate. So when you add 0 plus the root of 3, you're going to have this root 3. And then when you subtract 0 minus the root of 3, you're going to have this negative root 3, which is this other f2. I think that's what I just forgot. The vertices I explained. Yeah. Then these are the asymptotes. Even this one here. So let's look at now the hyperbola with the center h, k. So the hyperbola with the center h, k is given by that equation. Yeah. So for that equation, you have such a hyperbola. It's going to come out like this. Since my a is, since x is positive, so meaning we're going to have our hyperbola to come out in this manner. And then the equation of the asymptotes will be this. and that there's nothing that is new on this on these equations. The only new thing is that where there was y, instead of just putting y, you put minus k, and then is equal to b over a times, while there was x, you just have to put x minus h. That is the only thing which is unique there. But of course, these b and a interchanges. When you have your hyperbola coming out like this, it changes, instead of being b over a to be a over b. Yeah, so the transverse axis is parallel to the x-axis. The transverse axis is just this line there. It's parallel to the x-axis. So this is how it comes out. Then the vertices are there, h plus a. Yeah. And then you have the focus there. Then this is the equation. This is the equation now for the asymptotes. Yeah, so if you have such an equation where your y is the one which is positive, this is how your hyperbola is going to be coming out. So now let's try to take a look at this equation here. So when you're given such an equation, the first thing that you need to do is to express it in its simpler form, or in its standard form. So when you express it in the standard form, you're going to have the equation to be this one here. And then, meaning the center here is going to be positive 2, 3. Getting from this h, k, you get them from what is in the brackets there. You equate them to 0 to get these coordinates. And then the other thing that you need to find here is your c. How do you find c? C, we know to say c squared for the hyperbola is given by a squared and then plus b squared. So a squared is 4, and then your b squared is 9. So when you add the 2, you get the root of 13. So when you add the 2, you get the root of 13. So this is your c. So after finding your c, you now can even start sketching your graph like that, because you know to say just just by looking here, your a is going to be the square root of this 4 is going to be 2, and then your b is going to be the square root of 9 is the square root of 9 is 3. So meaning you're going to move 2 steps. First, we locate the center. The center is 2, 3. So the center is 2, 3.
So here A doesn't need to be greater than B, A
And
squared.
no. For this one, I said A is always on the positive number, on the positive part. So when you look at this part is positive. That's the reason why I've gotten 4 as A squared. This other part is negative. It's the one that goes with B. That's the way it is. Unless you're talking of, unless you're talking of an ellipse. For the ellipse, A is always greater than B. So you locate your center there, which is 2, 3. I'm just remaining with 10 minutes. So you locate your center there, which is 2, 3, and then you now move 2 steps. So my A is under Y, so I'm going to move 2 steps in the Y, going up. So I'll move 1, 2. So I'm going to have one of my points there. Now also move 2 steps coming down. 1, 2. So I'll have my point there, another point there. So from the center again, I'm going to move 3 steps to the right and to the left in the X. So I'm going to move 1, 2, 3. I'm going to have my point there. And then I also move 3 steps, meaning I'll find myself on -1 this side, like that. Then I'll draw my box like that. I'll draw like a small box. So this box is supposed to pass through this point. Then from there, I'll draw my asymptotes now. Yeah, okay. It's supposed to pass through the center. And then, yeah, so, sorry. Yeah, so these are my asymptotes. And then since this, my A is under Y, so meaning it's going to come out, so meaning my vertices are going to be there and there. Then my hyperbolas are going to be like that. So this is how they are going to come out. And then what else? The focus is just you add. So since I'm moving in the what? In the since my hyperbolas are in the Y, so I'm going to add and subtract the value of C from these 3 here. So it's going to be, so my focus there, the coordinate for the focus will be 2, comma, so this will be 3 plus the root of 13, 3 plus the root of 13, so 3 plus the root of 13, and then same applies to the down part here will be, it's going to be, I don't know if it will be down there or there, but what I know is that my point is going to be 2, comma, 3 minus the root of 13. This is the other f. So this one is f1, then the other one is f2. So these are the most important things that you need to find. So this is what I was talking about. Yeah, so this is the graph there. You can see it, it's there. So this is your f1, your f2, and then you find the vertices are just these points there. Okay. So this is the exercise that I prepared for you guys. I just want to see whether you've understood what we've been learning on conic section. And by the way, this is the end of the topic conic sections. So you can find time to solve these equations, I mean to discuss these conic sections, then submit. You can send me your solutions on WhatsApp, then I'll check through, I'll correct you where you're wrong and where you're correct. So yeah, I'll correct you where you're wrong. Yeah, so if you have any questions, you can ask. The next time we're going to meet, we're going to start calculus. Okay.
Mr. Teddy,
Okay.
if you haven't yet erased the previous slide, I want to see the standard form that you found.
The standard form. Oh.
Yeah.
Okay, let me check. You mean this part?
Oh, yeah.
Yeah. You've seen it?
Oh, yeah.
All right. Okay, you guys, this is the end of this lesson. Just make sure that you submit the exercise before we start
I've
calculus.
got a question.
Okay? You can ask.
What time are we supposed to submit the exercise today?
No, you can do it at your own time. But just make sure that I just want to see whether you have understood or not. Because if I say tomorrow, there are some people that are later 70 days, they will not be able to do it tomorrow. So just make sure that before we have our next lesson for calculus, meaning on Sunday, before 15 hours.
Okay.
Yeah,
All right. Thank you.
you're most welcome. All right, then I'm ending the meeting.